right, so you should probably try to write out these formulas on your own without looking at what I'm writing. So why don't you try to do that and then pause this and then come back and see if you're correct. Okay, so now we're going to apply them. So first question says write as a single term pi over 4 plus theta plus cos of pi over 4 minus theta. So that's really the cosine of 45 plus theta plus the cosine of 45 minus theta. I'm going to work it out in degrees. So I'm going to use the formulas from up above. So the cos of a plus b is what I'm going to use for cos of 45 plus theta. So it's going to be cosine 45 cosine theta minus sine 45 sine theta plus, so that's that first group, cosine 45 cosine theta plus sine 45 sine theta. That's that second cosine of 45 minus theta. Okay, so now let's see if we can simplify some things. I really do not need those parentheses. I just did those to show you. That's what I was grouping. So now I'm going to combine some like terms here. So the sine of 45 negative and the sine of 45 sine theta positive, those cancel. So those equal 0, and then we're just left with cos of 45 cos theta plus cos of 45 cos theta. So that is 2 of those cos 45's cos thetas. So that's 2 cos 45 cos theta. And then the cos of 45 is radical 2 over 2. So the 2's cancel, and I'm left with radical 2 cos theta. There's nothing more I can do. Number 2, write as a single term. So now what you have to do is look for the formula that this would go into. So this is really the sine of A cos of B minus cos of A, because they're both 25, sine of B. And if you look up top, that matches with the formula for the sine of A minus B. So then that means then, therefore, A is equal to 25 and B is equal to 10. So sine of A minus B is the sine of 25 minus 10, which is the sine of 15. And that's what that is all about. Write as a single term, and that's what we did. What is the exact value of the tan of 15? Well, if we write them using our 30, 45, 60, we know sine, cosine, tan, 1/2 radical 2 over 2, radical 3 over 2, radical 3 over 2, radical 2 over 2, 1/2, radical 3 over 3, 1, and radical 3. So if we can write the tan of 15 as a sum or a difference, so I'm going to go with 45 minus 30. If we use the tan formula, then we will be able to replace in the tan formula with tan 45 and tan 30, which we have values that we can replace. And so we can get the exact value. Exact value means radicals. It does not mean just punch it in your calculator and give a decimal. So the tan of 45 minus the tan of 30 is like the tan of A minus B. So that's the tan of 45 minus the tan of 30, all divided by 1 minus the tan of 45 tan 30. And so the tan of 45 is 1. Tan of 30 is radical 3 over 3. So we end up with a complex fraction. So what I'm going to do with that now is multiply everything by 3 over 1. That will be the easiest. So I'm going to do 3 over 1. The last complex fraction we solved together in class together, I did a form of 1 just for the denominator, but in this instance, these are going to cancel and it'll make it much easier if I do it this way. So this final answer is 3 minus radical 3 all over 3. Oh, I think I did this wrong. This one is supposed to be plus. So 3 plus radical 3. And then one last thing to do, rationalize that denominator. So I'm going to multiply by 3 minus radical 3 over 3 minus radical 3, because that will give me a denominator of 9 minus 3, because I have conjugates in the bottom. So 3 radical 3 minus 3 radical 3, the outers and the inners of FOIL are 0. So I just get 3 times 3 is 9, and radical 3 times radical 3 is 3. So that's become 6 in the denominator. And in the numerator, it is 9 minus 3 radical 3 minus 3 radical 3 plus the square root of 9, which is really just plus 3. So overall, we get 9 plus 3 is 12. Negative 3 radical 3 minus 3 radical 3 is negative 6 radical 3. All over 9 minus 3 are 6. And then divide everything by 6. 2 minus radical 3. So that was a complicated one, but that's how you do that one. Okay, next page. Right as a single term. Okay, so cosine 2x cos x plus sine 2x sine x. Formula is equal to the cosine of a minus b. That's cos a cos b plus sine a sine b. So therefore, a in the formula is, in our case, equal to 2x, and b is equal to x. So I'm going to go back and just plug this in and go with 2x minus x. So my final answer is just the cosine of x. Okay, next one, right as a single term. Sine, okay, all right, so we're saying no denominators can be 0. So let's just write out our formulas for the sine of alpha plus beta. So that's the sine alpha cosine beta plus cosine alpha sine beta. Let's get the one for that. So that's plus sine alpha minus beta. That's sine alpha cosine beta minus cosine alpha sine beta. All right, and then for my denominator, I just have cosine alpha cosine beta. So I see that the cosine alpha and the sine beta and the cosine alpha positive and negative, those cancel to 0. And then I have 2 sine alpha cosine beta. If you combine the numerator over cosine alpha, cosine beta. The cosine betas cancel, and so we end up with 2 sine alpha over cosine alpha. Well, sine over cosine is tan, so that's 2 tan alpha. Okay. Number 6, prove that for all values of theta. All right. So on that left-hand side, we're just going to use the formula for cosine of A plus B. Okay, so I'm going to use the cosine of A plus B equals cos A, cos B, minus sine A, sine B, excuse me. So I'm going to do cosine of 3 pi over 2, cosine theta, no parenthesis there, sorry, sine of 3 pi over 2, sine of theta. So the cosine of 270 is equal to, down at negative 90 or 270, the y-coordinate is 0 times cos theta, so those go, minus the sine of 270 is negative 1 times the sine of theta. So a negative times a negative is a positive, so final answer is just sine theta. And that's what we were trying to prove, that it equaled sine theta. And it does. All right, prove the following. So I'm only going to work with left side or right side. It's like there's a line here. The left side cannot see the right side, so you have to get the left side to equal the right side. So on the left side, I'm going to square that. So I'm going to do sine x plus cos x and sine x plus cos x minus 1 over cos x. So that's going to be sine squared x. When I do those in the last terms, I'm going to get cos squared x. And the inners and outers, it's going to be plus cos x sine x plus cos x sine x. So that's 2 of them. So this first part is equal to 1. And the second part has its own unique thing, that's 2 of those. So, and this is all divided by cos x. My numerator now, though, turns into 1 plus 2 cos x sine x. And that's all over cos x. So let's see if we can, oh, you know what? I forgot the minus 1. Okay, so I need to put the minus 1 on the end here. So there's minus 1. So that actually works out nicely because now the 1's cancel and I actually can simplify further. Now, because I get rid of those, the cosines cancel and I'm left with 2 sine x. So now I'm trying to get the right-hand side to say that as well. So the sine of 2x we had a formula for. That is 2 sine x cosine x. That was the one when we did the sine of 2u. And then tan is sine x over cosine x. And cosecant is 1 over sine x. So I can cancel those. And I can cancel those, leaving me with 2 sine x. And there's my proof. Okay, next one. Prove the following. Okay, same thing. Work with the left side, work with the right side. So the cosine of 2x we have a formula for that we could use. We could try the cosine squared minus sine squared. You get to pick one of the 3. So let's try cosine squared minus sine squared. That's equal to cos of 2x. And that's all over sine x plus sine x. Now I think I want that denominator to say sine x. So that's going to turn into sine squared x over sine x. Ah, beautiful. So now when I combine like terms, the sine squared x's cancel. And I just end up with cosine squared x all over sine x. You got to know your rules for fractions. I'm just combining them with the like denominators. On the right-hand side, I'm going to go with 1 over sine x minus sine x over 1. Again, I need to have that common denominator. So I'm going to go with 1 minus sine squared x all over sine x. And we know from previous that 1 minus sine squared is equal to cosine squared. So that's cosine squared over sine x. They are the same. You could go farther with cotan, but you don't need to. All right, so then which of the following equations are identities? For those equations that are identities, which ones are defined for all reals and which are not? For the latter, for which values of x are they not defined? So sine of x plus 2 pi equals the sine of x. So the sine of x, which ones are, so the sine of x plus 2 pi would be the sine of x, the cosine of 2 pi plus cos of x, sine of 2 pi. So the cos of 2 pi is 1 comma 0, so that's sine x times 1. And the sine of 2 pi is 0, so this is just cos x times 0, so that goes. So sine of x equals sine of x. Okay. So that one is definitely an identity. If it is an identity, which ones are defined for all real numbers and which are not? So this should work for all real numbers. That's its domain. All right, sine of negative x equals sine of x. It is not an identity. Sine is an odd function. And so therefore, sine of negative x equals negative sine x. Okay, so the sine of negative x does not equal positive sine x, so that is not going to be true. And then the last one, this is the cofunctions rule, so this is an identity. And it would be an identity for all real numbers. There's not going to be any undefineds at all in there. Okay. And I believe that's it. Okay. So, have a good night then.